Live from the central coast of California, this is NASA's launch coverage of JPSS-2 and LOFTED. In just about 39 minutes, we'll watch as this United Launch Alliance Atlas V rocket lifts off from Vandenberg Space Force Base. With this one launch, we have two missions today. The primary one is to deliver JPSS-2 into orbit, which is the newest polar orbiting weather satellite. The secondary mission is called LOFTED, which will demonstrate an innovative inflatable heat shield. Hello and welcome to Vandenberg Space Force Base in California. I'm NASA's Megan Cruz, coming to you live from the Nerve Center for all launch vehicle and spacecraft processing at Vandenberg. I'm sitting just a few feet away from NASA's Mission Director Center and Launch Vehicle Data Centers, where teams are working on today's launch. Managing the launch is NASA's Launch Services Program, or LSP. Today's 36-minute launch window opens at 1:25 a.m. Pacific time. Now, we've got a whole lot planned for you over the next 3 hours. You're going to see that Atlas V rocket launch live. Also, live reports from NASA's Angelique Herring in Virginia, who's with the LOFTED team at Langley Research Center. And we, of course, have our talented team of commentators who will walk us through every important milestone today. And right now, that's going to be NASA's Daryl Nail and Mick Waltman. Guys, NASA and ULA called off the launch last week, right, because a battery needed replacing.
That's right, Megan. It had to do with the flight termination system, a critical component to the launch of the rocket today. And that battery has been swapped out, some work that happened over the past weekend. Daryl Nail with NASA, Mick Waltman, engineer with Launch Services Program, here to count you down through this liftoff of JPSS-2 and LOFTED. And so far, this countdown, which began 7 hours ago, Mick, things are looking good. They cleared the pad at Slick 3, Space Launch Complex 3. You see the Atlas V rocket on the pad venting off that liquid oxygen. They fueled up Atlas V and Centaur and tested that flight termination system. It's all good, including that new flight termination system battery that was replaced, causing that 9-day launch. But there's also an issue that we're tracking now regarding the liquid oxygen in Centaur.
Yeah, absolutely, Daryl. The teams came on station early, as you said, and they've been working through these things. The FTS battery, we replaced that with a new battery, and that's going well today. The issue the team's working right now is as they're filling the vehicle with liquid oxygen, they are working a valve issue on the ground. They are still able to maintain filling the vehicle and topping the vehicle, but the team is talking through that, working through their procedures, and we'll see how that resolves here throughout the rest of the count.
So it did push the rollback of the mobile service tower just a little bit into the night, but we did get rollback, and we got video of that. And there you see it, time-lapse video of the mobile service tower rolling back from the Atlas V rocket. A beautiful sight here in Vandenberg, California, as you watch that roll back, and especially today, Mick, for the last Atlas V to launch from the west coast of the United States.
Yeah, absolutely. Last Atlas V from Space Launch Complex 3, 41st Atlas in this 401 configuration, which I know we'll talk about a little bit later. But very excited for this mission today with JPSS-2 and LOFTED on board as LSP's 100th mission getting ready to launch.
Unique mission today, dropping off the JPSS-2 satellite and LOFTED. We'll talk more about that in a bit. Launch time exactly 1:25 a.m. Pacific Standard Time, 4:25 a.m. Eastern Time. Back to Megan.
Now, once in orbit, JPSS-2 will join two other polar orbiting satellites in the National Oceanic and Atmospheric Administration's, or NOAA's, Joint Polar Satellite System. That means the satellites travel back and forth between the North and South Poles while the Earth spins underneath it. This orbit allows the satellites to observe the Earth twice a day, giving us timely and accurate weather forecasts.
Sitting on Launch Complex 3, at Vandenberg Space Force Base is, one could argue, one of the most valuable single objects on the planet. Once in orbit 512 miles above our heads, its data will save lives, safeguard property, and read the vital pulse of the planet. The 4 instruments aboard the JPSS-2 satellite will provide continuous observations of weather, oceans, global temperatures, forest fires, volcanic dust plumes, and much more. JPSS-2 will join a fleet of other vital Earth-observing satellites, including the first 2 in its series. In all, there will be 4 JPSS satellites launched, ensuring at least 2 continuously in orbit well into the 2030s. Covering the entire planet twice a day helps us plan for severe weather, like hurricanes, floods, and snowstorms. And the data continuity it provides allows us to create an archive of atmospheric temperature and ozone measurements while monitoring our changing climate. JPSS nighttime imagery provides a view of the human footprint on Earth by showing lights from cities, highways, shipping vessels, and gas flares. Patterns we see over time in these night lights reveal how world conflicts and natural disasters impact our energy use. Commissioned and operated by NOAA and built and launched by NASA and its commercial partners, the JPSS series of satellites represents the latest in a proud 60-year history of orbiting weather platforms. Most people don't realize the contributions JPSS satellites make to their daily lives, but that data is with them every day in every single weather forecast.
And the Joint Polar Satellite System is working for us as we speak. About an hour ago, Hurricane Nicole made landfall on the east coast of Florida as a Category 1. The satellite system is analyzing it from above to help inform weather forecasts, just as the system did for Hurricane Ian, which made landfall in Florida also as a strong Category 4 back in September. It destroyed homes, businesses, and claimed more than 100 lives. This image right here shows the sheer size of the hurricane, covering all of South Florida. And we have the second image now. This one you can make out the state a bit better because here we're highlighting the lights of Tampa and Miami there. So both were captured by NOAA 20, which launched in 2017 as the second satellite in the system. Now let's go over the specs of the soon-to-be launched JPSS-2. It weighs more than 5,500 pounds at launch. That's roughly the weight of an adult male rhinoceros. And its size, you want to picture a monster truck, 7 feet wide and more than 14 feet tall. But when you deploy its 35-foot solar array, it becomes as long as a 3-story building. Once in orbit, it will fly 512 miles overhead and travel more than 17,000 miles per hour. At that speed, in the time it takes you to watch one movie, JPSS-2 will have circled the planet once. Okay, now JPSS-2 wasn't built in one place. Its main body or spacecraft bus, along with the 4 instruments on board, were built in Indiana, Colorado, and California. Once ready, everything was assembled and tested in Arizona. Finally, it was shipped here to California for launch in just about 31 minutes. Now, NASA's Jasmine Hopkins got to speak with JPSS Program Director Tim Walsh about how JPSS-2 is unique.
Joining us now is Tim Walsh, JPSS Program Director. Thank you so much for being here, Tim.
Thank you, Jasmine. Love being here tonight.
Of course, we're super glad to have you, and it's very exciting preparing for launch. So JPSS is not just focused on forecasting our local weather, but global weather systems. How does that work?
So tonight when we launch, we're going to launch due south, almost due south over to the poles. And so we're going to go around the Earth 14 times a day from pole to pole. When we do finish raising the orbit, when we bring the orbit to its final position, we'll be 515 miles off the Earth. And by that, we'll be in a special orbit called sun-synchronous orbit. And in that sun-synchronous orbit, we're in a fixed position relative to the sun. And while the Earth rotates underneath us, we see the whole Earth more than twice a day.
Oh, wow. That's exciting. Must be moving pretty fast then.
It is quite fast.
Awesome. So JPSS-2 is actually the third in this satellite series. What makes it different from the previous satellites?
So there's some really important differences. First of all, it's a new spacecraft. The satellite itself is new. The instruments are identical to the ones that are in orbit, but the satellite is brand new, and we're going to be testing it very thoroughly over the next 2 weeks. And then over the next 3 months after that, we'll be testing all the instruments.
Right.
And when we're in orbit, we do have one instrument that's a little bit different than the previous, and that's one that measures ozone at the Earth's limb, with the edge of the Earth's atmosphere. And by that, we can get really good ozone profiling of the atmosphere, and it's used, among other things, to provide UV index forecasts.
Right, so it's helping us better understand the global environment.
Correct.
That's fantastic.
Correct.
So it won't be the last one. JPSS-2 will be followed by JPSS-3 and 4. How are they all going to work together?
Well, JPSS, the last S stands for system, and so it's really important to note how we have 4 satellites, 5 if you include our predecessor, SNPP, that all work together to provide a continuous data record from 2011 all the way into the 2030s. And by doing that, we can keep a close eye on how the climate is changing over time, whether it's temperature or other things. And so we could look at severe weather in the near term, we could look at climate in the long term.
Fantastic. Tim Walsh, thank you so much for joining us today.
Thank you very much.
Fantastic. Back to you.
A successful launch today will mark the 100th for NASA's Launch Services Program. LSP is based out of NASA's Kennedy Space Center in Florida. The program has matched commercial launch providers with organizations needing a ride to space since 1998. Their uncrewed rockets have flown weather satellites, telescopes, Mars rovers, and more.
3, 2, status check, proceed with terminal attendant. Sequence 4 minutes scouting from launch director. LD is go and
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
A rocket launch is anything but boring. I mean, it's exciting. No matter how many times I've seen it, it never gets old.
When you talk about launch, it never gets old, right? Each mission that we work is different. Each day that we are supporting these missions is different, so it never gets old.
And liftoff.
There's something about witnessing just the sheer impressiveness, just the power of what it takes to pull a spacecraft out of the gravity well of Earth that we live in and to send it out of Earth's orbit on its way to the moon, Mars, the sun, asteroids, even out of our solar system. I'll never tire of watching that.
It never gets old. It really never gets old.
Seeing rocket launches never gets old.
It never gets old. You always are thinking about what's the next one? What's the next one I could do?
This was my childhood dream. This is what I dreamed of doing. And you get to be a part of something that's so much bigger than yourself. And to me, that was the best thing that my childhood self could ever ask for.
And to celebrate LSP's 100th mission, we'll learn more about the program and meet more of its team throughout this broadcast. Okay, we are now 26 minutes and counting from liftoff of an Atlas V rocket for 2 missions today. Let's go back to NASA's Daryl Nail and Mick Waltman, who have the latest weather forecast for launch.
Yeah, that's right, Megan. We're actually listening right now to the weather brief being given at L-26 minutes and 30 seconds. So it's running a little bit late, but we know that the launch weather officer has put the launch weather at more than 90% go. That's a great sign.
Yeah, great sign. Launch weather officer is telling us from the Space Force that everything looks green tonight. All the weather is great. The front that we had the last couple of days has moved through. As you can see in the picture, clear skies this evening. Perfect temperature out there for this Atlas V mission.
You can see a clear black sky. Of course, not really. If there were clouds, you wouldn't see them, but we can tell you that at the moment, there's not a whole lot out there. And take a look at the satellite loop to explain. There it is. We are on the central California coast, launching from Vandenberg. You can see a system to the far right that's gone past us. That brought a lot of rain, but it's exiting, bringing us clear conditions. Launch Weather Officer Zachary Zonas says that we could still see some lingering moisture and instability, but it's a very low chance. In fact, his forecast says we are more than 90% go for launch weather tonight, with the only concern for cumulus clouds and temperature. You can see right now we are about 44 degrees outside, that greater than 90% go. Winds are 7 to 12 miles per hour out of the north. And that rain on the ground is actually keeping us a little warmer. So that's a great forecast for today.
Yeah, absolutely, Daryl. I couldn't ask for better weather to get JPSS-2 and LOFTED on its way this morning.
As for the backup day, Captain Zonas says we are down only a smidge to a full 90% for launch weather, thanks to a high pressure settling over the area and causing a weakening of the winds and more stable conditions. Now, in about 6 minutes at L-19, you'll see the T-clock go into a built-in hold, and we'll talk a little bit about that, but we are T-minus 24 minutes and counting until liftoff. Let's send it back to Megan.
Thank you both. So once NOAA's JPSS-2 reaches orbit and we confirm a signal, our focus will shift to LOFTED, which stands for Low Earth Orbit Flight Test of an Inflatable Decelerator. I stress the word inflatable because current heat shields are rigid, made of materials like ceramics or metals. That means the size of the heat shield is constrained by the size of the rocket taking it up. But a flexible design can be folded up, taking up less room during launch and then inflating into a larger shield when it's time to land, meaning more room for experiments, equipment, and people for future farther trips like the Artemis missions.
NASA is demonstrating inflatable heat shield technology that could help land humans on Mars. This technology is hitching a ride with NOAA's Earth-observing satellite JPSS-2 on a United Launch Alliance Atlas V. Once in orbit, the satellite separates and the payload adapter canister surrounding LOFTED jettisons. About 90 minutes after liftoff, the LOFTED technology demonstration begins with the inflation of the aeroshell. The upper stage of the rocket reorients and positions LOFTED for entry into Earth's atmosphere. The re-entry vehicle spins and separates from the upper stage. During re-entry, sensors and cameras collect data. A beacon transmits real-time data every 20 seconds throughout the mission. Several minutes into descent, an ejectable data recorder releases. About 2 hours after launch, a parachute deploys and LOFTED splashes down in the ocean off the coast of Hawaii. A team from NASA and ULA recover the data recorder and aeroshell. This test will help inform entry, descent, and landing technologies for future human exploration missions to Mars.
Now, before arriving at Vandenberg, the heat shield underwent environmental testing at NASA's Langley Research Center in Hampton, Virginia, to make sure it was flight ready. NASA's Angelique Herring is at Langley with what researchers hope to learn this morning. Good morning to you.
Good morning, Megan. I'm here outside of the Flight Mission Support Center where we've got some members of the Langley LOFTED team here, and they're going to be taking in data from today's exciting demonstration. Now, all the data that they take in today is actually going to help them to develop the HIAD technology even further. HIAD standing for Hypersonic Inflatable Aerodynamic Decelerator, essentially an inflatable heat shield. And this inflatable heat shield technology could help us to not only travel farther, bringing more things with us as we continue to explore outer space, but also to do so more sustainably, which is incredibly exciting. Now, for today's demonstration, once the reentry vehicle actually powers on, we'll have a beacon on board that will be relaying data to us every 20 seconds. Now, that data, the health and telemetry data, along with the real-time location data, will be monitored right here at the Flight Mission Support Center. Additionally, we'll be getting some imagery and other data coming in from the many different cameras and sensors on board, so make sure you stay tuned in for all of those updates and so much more. Back over to you, Megan.
Now, today is dedicated to two very special people. We have a picture of their names engraved on the rocket. There you see Bernard Cutter and Mark Levesque. Cutter was a ULA engineer who had a special interest in inflatable heat shields. He was an advocate for lower cost access to space and the technologies that could make that a reality. Cutter took interest in NASA's heat shield technology, which could enable the safe return of Vulcan rocket engines as part of ULA's reuse program, as well as land large payloads on Mars. But sadly, Cutter passed away in August 2020 before getting to see the inflatable technology in use. We also have Mark Levesque. He was an aerospace engineer and launch conductor for missions launching on Delta II, Delta IV, and Atlas V rockets. After an early retirement from ULA, Levesque worked on special projects for NASA's Launch Services program. After a long battle with cancer, Levesque passed away last year. We're going to talk more about both men's contributions to space exploration ahead in this broadcast. Now, tracking and understanding climate change is a big priority for NASA. So joining me now is Dr. Thomas Zurbuchen, Associate Administrator of NASA's Science Mission Directorate. Good morning to you, Dr. Z.
Hey, good morning.
Glad to have you here. You know, I want to talk to you about NASA and NOAA. You know, they've been monitoring our planet together for more than 6 decades. You know, what do you think about this partnership?
Well, it's one of the most productive partnerships in the U.S. government and frankly worldwide. We've built the spacecraft, we've worked together, and we've also built models. We've done science that we then turn over to NOAA, our partners who are using it each and every day to help our citizens and beyond.
Yeah, and specifically looking into climate change like we were talking about, you know, what are the effects of our climate changing so drastically, and how are we as NASA trying to address that?
So climate change is a hugely personal thing for all of us. We may not notice it every day, but it's affecting our lives in a direct fashion. Some of the changes are slow. You know, like this much is the water level around the world going up each year, you know, 3-4 millimeters and so forth. But there's also really drastic changes, which are more storms, more fires that really are affecting our property and are affecting lives. And I think both of these really matter, the abundance of these events, but also the slower changes.
And tracking it helps us to address it. So that's why we do things like this with NOAA. I do also want to talk about that after JPSS-2 launches, NASA will test this new inflatable heat shield. If all goes well, how could this technology revolutionize space travel?
Oh, I'm really psyched about this. Of course, you know, we at the Science Mission Directorate have inhabited Mars with robots for 20 years, and we're there right now with a lander, a rover, you know, its flying companion Ingenuity. But we want to go there with humans. First of all, with Artemis to the moon and then to Mars. But to land on Mars, we need new technology, and it's this LOFTED technology that we believe is absolutely essential for us to do that. So it's a huge step, in my mind, a huge step in the direction of human exploration of Mars.
I have a feeling you're going to be glued to the screen watching the flight test today.
That's right. I'd like to teleport to Hawaii to see it coming down.
Well, take me with you if you do that.
Okay, let's.
Thank you, Dr. Z. I appreciate your time.
Appreciate it, Megan. Thanks.
And after JPSS-2 comes other satellites, and we'll talk to you more about that. But JPSS-2 comes a decade after the first one launched in the series. So let's take a look at how that satellite has helped us over the past 10 years.
Ten years ago, a remarkable suite of instruments took to the skies aboard the first of a series of polar orbiting weather satellites known as the Joint Polar Satellite System. This is the story of the satellite that led the way. It has measured storms, fires, volcanoes, and oceans, changing the way we view the Earth, improving our weather forecasts, and carrying on critical long-term measurements of our planet.
4, 3, 2, main engine start, 1, 0, and liftoff.
On October 28th, 2011, the Suomi NPP satellite lifted off on a Delta II rocket from Vandenberg, California. Named after Werner Suomi, who invented the first spin-scan camera to observe weather from space, the satellite marked the beginning of another new era, the Joint Polar Satellite System, a mission to provide valuable weather and environmental data into the 2030s. And during the last decade, Suomi NPP has become well known for its blue marble images and also its day-night band, which show us power outages after storms and human activities at night, such as highways, sea travel, and natural gas flares. Continuing observations begun by satellites like NASA's Terra, Aqua, and Aura, it allows for a number of products that help people on the ground. Its data allows us to map wildfires, track the movement of wildfire smoke, and then measure the air quality as that smoke moves through an area. Measure the insides of hurricanes and reveal the structure and intensity of a storm and the ocean's surface temperature that fuels it. Track the health of major crops worldwide by showing how they're impacted by weather and temperature. And measure emissions from volcanoes that help determine air quality and visibility for pilots. Over the last 10 years, NPP data has increased our understanding of major events, Australian bushfires, Saharan dust storms across the Atlantic, and emissions decreases from the global pandemic. The Joint Polar Satellite System's next satellite launched 6 years later in 2017, and its sister satellites will launch over the next decade, continuing these kinds of vital measurements in the years to come.
And those two remaining sister satellites will be nearly identical to JPSS-2. JPSS-3 will launch in 2027, JPSS-4 in 2032. Okay, we're now 14 minutes, 27 seconds to liftoff. Let's head back over to Daryl and Mick as they await the NASA Launch Manager poll.
Yeah, that's right, Megan. We are here at the Mission Directors Center listening into the loops and the teams discussing a number of things. We've got that poll coming up at L-13 minutes. Currently, that's about 1 minute and 10 minutes away. There you can see the ULA launch team and NASA Launch Manager Omar Baez, who is in the second row, second person from the left. You can see him on the phone there. He is the one who will be conducting the poll that we'll be listening into. Mick, quickly, we know that the teams have been discussing a matter regarding Centaur locks. What can you tell us about that, and where do we stand?
Yeah, so the team's been discussing a valve issue they've had. They've been following all evening and thought they had under control, and now they're continuing to look at that as they move forward. NASA Launch Manager Omar Baez is talking with ULA Launch Director Paul Aragon about the go-forward plan. The engineering teams are looking at all the data and trying to assess where we are as we get ready or get close to 100% fill and topping of the Atlas and Centaur tanks of liquid oxygen. So the team is still working in that as we're in this built-in hold, and they continue to assess where they're going.
Going to delay the L-13 poll and work through the finishing the topping of the LOX tank here and make sure we target a correct T0. It looks like we've blown through the first green block, and the initial target would be that 949 UTC, but let us work through that, through this these final steps here before we reestablish, and I'll come back with a good target for the final poll.
So Daryl, there we heard Launch Manager Omar Baez talking about them working through it and targeting a new T0 that they're going to negotiate, and we'll see how that goes as we head into this topping of LOX.
So indeed, we have a 36-minute window for the launch today, and so the team looking at the possibility of using some of that window, Mick. And real quickly, we do know there's a COLA at the 4th minute that they're going to be aware of if they do go into this window.
Yeah, as we heard Omar say, he would be targeting, his first attempt would be 129. That's because the minute at 128 is unavailable to us due to a possible COLA avoidance of another satellite. So they would start with 129 and then work down from there.
All right, thank you, Mick. And we'll be tracking the countdown as we go, as well as monitoring any changes to the countdown and the T0. But for now, we'll send it back to Megan.
Thank you for that update, Daryl and Mick. NASA's Launch Services Program helps launch the satellites, which NOAA will then operate. NASA's Jasmine Hopkins shows us how NOAA continues its legacy as a watchful eye from space.
Joining us now is Dr. Michael Morgan, Assistant Secretary of Commerce for Environmental Observation and Prediction from NOAA. Thank you so much for joining us, Dr. Morgan.
Thank you very much, Jasmine.
Great. We are so happy to have you here. So you have been working for NOAA in a very large role. Can you tell us about the NOAA and NASA partnership? Why is that so important?
That partnership is important because NOAA maintains an observational portfolio that's authoritative, and the analyses and predictions that we do are important. But in order for us to achieve this, our mission, we work closely with NASA in partnering to develop and build our satellites and help launch them. And also NASA helps us with our ground stations as well to track the satellites. Additionally, separate from our observational portfolio, our global model shares the same dynamical core as NASA's.
Oh, wow. And you've been working pretty closely with those different models. I understand that you've been tracking things with ground and radar. So how does the information from NOAA help us across the board, from policy making to different prices and things?
Well, with this particular satellite, JPSS-2, the data is going to be important for understanding the temperature and moisture structure of the atmosphere. The VIIRS instrument that's on this particular satellite, which stands for Visible Infrared Imaging Radiometer, is going to allow us to look at ocean color, which is important for identifying harmful algal blooms. For severe weather forecasting, for short to medium range forecasting, these observations are imperative for us to have in order to have high-class prediction.
Right, and I also understand that JPSS-2, like the other weather satellites from NOAA, really help us understand climate change, and they've been doing that for decades. So what is JPSS-2 adding to that?
What JPSS-2 adds, it really maintains a continuity of our observations of the ozone in the upper troposphere or lower stratosphere. That's important for the radiation protecting us from the harmful ultraviolet radiation which can reach the surface. So by accurately measuring the ozone quantities as well as clouds, we can improve our forecast of UV at the surface. The long climate record that's maintained by these satellites, both for temperature and water vapor, help to build a long, extensive climate record which we can then validate with our models.
Fantastic. Dr. Morgan, any final thoughts before launch?
As a kid, I got excited about NASA by watching the launches of the Apollo mission, and it was great just prior to launch having an opportunity to walk by the spacecraft and see both the NOAA logo as well as the NASA logo on these machines, on this rocket.
Right.
And it was just incredible. But the partnership, the work that's been done by NASA and by the contractors and by folks within NOAA to make this a reality, I think is just incredible, and I really thank them for that.
Right, exactly. It's great to see this partnership working together for launch. Dr. Morgan, thank you so much for joining us today.
Thank you.
Of course. Back to you.
As we've said, after JPSS-2, we will test a new inflatable heat shield so that we could one day go to the surface of Mars, and LOFTED, that heat shield, will help us do that. But before that, we're returning to the moon. In just 6 days, NASA will attempt to launch this rocket and spacecraft from Kennedy Space Center. You're watching video from when teams rolled it all to the launch pad last week. The Artemis 1 flight test will be the first of increasingly complex missions to eventually return humans to the lunar surface. The last time humans stepped foot on the moon was 50 years ago. Scan the QR code on your screen to learn more about the upcoming launch attempt on November 16th, so just 6 days from now, and what's planned for our Moon to Mars program. We're going to check back in with Daryl and Mick now. They had an update for us a couple of minutes ago that the launch manager poll was delayed. Let's go back to them to see if they have any updates for us. Guys?
Yeah, thank you, Megan. We are currently at L-7 minutes and counting and expecting a poll from the launch conductor here in just a few seconds. Let's listen in.
L-7 minutes.
Now, we heard some discussion on the loops, Mick. We know that the NASA launch manager poll, which was at L-13 minutes, was delayed by launch manager Omar Baez. We're currently waiting the L-7 poll, but we know they've been working some things.
Yeah, working through this LOX issue, which now they have resolved and have a plan forward to do some manual monitoring and some work for topping of the Atlas LOX tank and the Centaur LOX tank. And I believe what we will be waiting on at this point, Daryl, is NASA launch manager Omar Baez and launch director Paul Aragon to come up with a new T0 time. We are definitely off of our 1:25 a.m. Launch attempt. As you heard Omar say earlier, we would look at 1:29 a.m. would be the first one. But based on some of the discussions we heard, I think we're going to be looking a little farther in there as they negotiate this time for a possible 1:36, which would change some of the polls that we are working.
That's right. And so, as you mentioned, looking for that new T0, we will continue to see the clock count down. But just again, to repeat what Mick said, we'll be looking for a new T0. Currently, we have a 35-minute window with which to work, and the launch team then corresponds to a 30-minute hold, which they can do at L-4 minutes, where they sync up with the T clock. Talk a little bit about what we're seeing in terms of how that works. The L clock just 60 seconds away from syncing up to that T-4 minutes, where they can hold for a bit of time till they get this new T0 worked out.
Yeah, so throughout the count we have these built-in holds. Tonight's were 30-minute holds just prior to cryogenic tanking at T-2 hours, and then of course, as you just mentioned, the 30-minute hold prior to the T-4 and counting. And that we work that on the L clock, which is a clock that continues to count down through the count, and the T time is the clock for liftoff as we get to off. And as we said, the clocks sync up at T-4 time and pick up the count there. But as we can hear on the loops, the team is definitely working to try to figure out that new T0 and where they're going to bring the clocks together.
Now let's listen into the launch
Below
team.
99.55. Roger. Probably because they're doing pogo charge, so copy that. LOX 1, LC.
Go.
Yeah, are you active with Atlas L2 topping?
We're still trying to get the film drain valve open with the line chilled. We haven't entered pogo yet. Stand by.
So we just heard some of the communications from the launch director, Doug Lebo, there as he works this team.
Yeah, Daryl, and what we've seen is the clocks have actually stopped at T-4, which means we're still in a T-4 on holding time, and we're eating up part of that 36-minute window that we talked about. And the window remaining is about 35 minutes now in our tonight's launch availability. And they'll continue to burn through that availability as they work through this problem. And then they'll figure out the new T0 and clock.
Previous T0 was 1:25 a.m. Pacific time, 4:25 a.m. Eastern time for the launch of the JPSS-2 and LOFTED mission.
So Daryl, yeah, as we were listening through here, as the team continues to work this issue with the topping, they're at 99.995%, doing some pogo charging on the first stage.
That's the topping, just to be clear, the topping of the locks on the Centaur liquid oxygen tank.
Correct, okay. Centaur locks. And so we're doing some pogo charging to get ready for liftoff, which takes away a little bit of locks. And so once that's done, they'll start their slow fill again to get back to that 100%. And I do know that we've heard NASA launch manager Omar Baez talking to the team, spacecraft team, engineering team, and the ULA team, looking for targeting a new T0 a little later this morning. We have not heard the official T0 time, so we're still counting down through that window that remains. We have about 33 minutes left in that 36-minute window of availability today. So we sit at T-4 and holding while the team continues this. And as just so people understand, this is a process. The team has procedures in place, and they are following them to the T. And one of the low priority things is to re-sync the clocks right now as they work through this issue on the rocket. So once they've work through that, then the team will come back around and sync the clocks back up and figure out where they're going from there. But we have this T-4 hold in place for this reason, to be able to work things. And of course, as we just continue working through the time, that availability in the window just dwindles down ever so slightly.
And you're looking live inside the launch room at the United Launch Alliance headquarters here at Vandenberg Space Force Base, as they currently, as Mick said, working through the Centaur locks issue. And we have heard them discuss the possibility of a new T0 24 minutes off the original. They're looking at the area of 1:49 a.m. Pacific time, 4:49 a.m. Eastern time, but they have not locked that in because, as you said, locking in the time isn't the priority. Currently working the matter at hand is.
Yes, we want to make sure the rocket is safe. We want to make sure the spacecraft is safe. We want to make sure everything's ready for launch. And if we need to do something, then we'll work that. So we'll use up as much of the window as we can as we continue to work this issue. And then the team will have to make a decision as we get down in those short strokes of the remaining time. But as you and I are listening to some of the engineering discussion, the team is definitely following their procedures methodically, going through some troubleshooting and discussing path forward. So the team is doing exactly what they are trained to do and make sure that the rocket and spacecraft are still safe before we lift off this morning.
Be advised, we are back into topping and we are picking up with the pogo charge.
Roger.
So there we talked about pogo charge earlier. We heard the team just talking that they finally...
I have an expedited outbrief for you.
Go ahead.
Okay, so the team struggled, but we did get the booster LOX tank into topping. We have reviewed the terminal count sequencing and have no different actions to take because of our condition with the 401 valve. Our recommendation is proceed as is with terminal count.
Roger.
Well, good news there.
Yeah.
Proceeding into terminal count, they've gotten the issue with the booster LOX resolved. They've got a plan.
Yeah, and that was great news to hear from Anomaly Chief Dave McFarland from United Launch Alliance to hear that they've resolved that and they've got into topping and that they'll get ready to go.
LC on 1, this is RLM. Go ahead. Booster LOX is back within band. Press permission to acknowledge alarm. Proceed.
So, Daryl, yeah, as we get ready to go, now that they've resolved that, we'll see what Omar Baez does with the T0 time. And as he gets ready for polling and working that T0 time and announce that, then we'll reset the clocks to be able to sync up and move into terminal count, as we heard Anomaly Chief Dave McFarland's recommendation to continue.
Charge is complete. Roger.
So a little more time for the last Atlas V to launch from the West Coast here in California.
LC, LOX 1. LC, LOX 1.
Stand by 1 for LC. Go ahead, LOX 1.
Atlas LO2 at play level.
Roger.
So that's great news to hear that the booster Atlas LOX is at flight level, and they continue their topping of that LOX in the tank. And so we'll continue to move through the procedure, make sure LOX is filled completely in the Atlas and the Centaur vehicle to then get ready for a new T0 this morning. We are still counting down through the window remaining. Daryl, we have about 28 minutes left in our window this morning. So the team, I'm very happy to hear the team is continuing to follow their process and procedures, work through all the things they need to work through, and get us to a safe launch this morning.
And we want to underscore the importance of what was just said there with regards to that flight level for the booster. That was a little bit of a sticking point they were trying to get past, and that's a great sign.
Yeah, as Anomaly Chief Dave McFarland mentioned, they were having some trouble with the booster LOX tank and getting ready for topping. They got that resolved and have moved forward. So absolutely, it's a great sign to hear that. And as we move into finalizing Centaur topping and get everything ready for flight levels.
And so we await the NASA launch manager poll. Omar Baez, in his last mission as NASA launch manager for the Launch Services Program, getting a little extra time in the seat himself.
Yeah, Omar did announce his retirement for later in 2023 or early 2023. So as you said, his last mission as NASA launch manager here on the JPSS-2 mission, and having a little excitement here in the last few minutes of this launch of an Atlas V from Space Launch Complex 3.
And so Omar indicated that he would like to conduct his launch manager poll. When that is ready to go, of course, we'll bring that to you live as it's happening. We're listening in for an indication of when that might start. At the same time, they're also working on hammering out that new T0. As we look live at the Atlas V, all 19 stories of it, at Space Launch Complex 3 here at Vandenberg Space Force, a historic pad here.
Yeah, Daryl, we talked about the 401 configuration earlier as the team continues to work these things. Interesting, as we look at the rocket here, you will see a 4-meter fairing on top. It is the last 4-meter fairing also for the Atlas V program. Built in Harlingen, Texas, hand-painted with the logos on board. It is the EPF, the extended payload fairing that Atlas offers in this configuration. And the reason we had to do that was J2 is the size of J2 and the height, as Megan pointed out earlier. But we also have that lofted mission that sits underneath on inside some canister spacers. So to be able to accommodate both of those, we needed this extended fairing. And you know, for me to see this last 4-meter fairing launch from Space Launch Complex 3 is another historic moment, along with this last Atlas V out of Vandenberg. So just another unique thing. There you see a
There's
great
that
shot.
hand-painted logo.
Yeah, great shot of that hand-painted logos of the JPSS-2, NOAA, NASA, and LOFTED. It was pretty cool to watch that being done by the artist who's been doing them for the last 25 years. And so another great historic moment for the Atlas V program.
It really is interesting as you look at that 4-meter fairing to think about how it actually has two vehicles in there. The spacecraft JPSS-2, which is at the very top of that fairing inside, if you can envision, and then below it is lofted, contained in a payload launch adapter and compressed all the way down.
Deflated, I believe, is what it's
Did
called.
I say
right?
inflated?
Deflated.
Deflated, yeah. That's what's an important difference.
LCLD on one.
It will
Go ahead.
inflate.
Yes,
Let's
it
listen
will.
in.
Yeah, I'd like for you to coordinate a new T0 of 094900 Zulu.
Roger. RCLC. RC on one. Roger. Please coordinate a new T0 of 09:49 Zulu. Roger. In work. And ALC. LC.
ALC.
Roger. Please set the countdown clock for a new T0 of 09:49 Zulu.
0949. Roger.
So we got a new T0 at 1:49 a.m. Pacific time, 4:49 a.m. Eastern time, as you just heard it called out by launch conductor Doug Lebo, and that's a great sign. We're going to eat into the window a little bit, but we've got a new T0.
Yeah, absolutely. We've eaten.
right,
we've used up
LC,
part of that window
LC.
remaining.
Yes.
T0 is set for 094900.
Roger.
Which gives us about 12 minutes left in the window if we need it. And we're now in the T-4 hold with about 11 minutes left in the hold. So we're at L-15 minutes, Daryl, coming up. So we should be picking things back up with our normal procedures.
Starting at L-13 minutes at step 60.
And so we'd be looking for that NASA launch manager poll at L-13 minutes by Omar Baez. And then we would continue to work our way down. Again, if you're just joining us, this is the launch of JPSS-2 and LOFTED on an Atlas V rocket off the western coast of California here at the Vandenberg Space Force Base. We've had a delay in our launch, originally scheduled for 1:25 a.m. Pacific Time, 4:25 a.m. Eastern Time. We've got a 24-minute delay. Our new T0, 1:49 a.m. Pacific Time, 4:49 a.m. Eastern Time. The Atlas V sitting on the launch pad at Space Launch Complex 3. A historic launch complex. Mick, I know you know it well. And this will be the last Atlas V that will lift off from this pad before this pad gets reconfigured for ULA's next generation rocket, the Vulcan.
Yeah, Vulcan Centaur will be the next, and the team will start making mods for that. Just like we did back in 1999 when we modded this pad to go from original Atlas ICBM rockets to the Atlas 2AS, part of the Atlas family, and then extended the mobile service tower for Atlas V as we get ready to launch today. So another great performance by Atlas V here on the West Coast for all the missions that they have launched, and we look forward to closing out this part of Space Launch Complex 3's history as we get ready to hear from Omar Baez, our NASA launch manager, on his NLM poll.
Yeah, let's listen in now to our NLM net, as we call it, the NASA launch manager, Omar Baez.
L-13 minutes.
This is the NLM on the NLM net with our final launch poll. NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA Mission Manager.
NASA Mission Manager is go.
LSP.
LSP is go.
NASA's ready to proceed.
So there we heard Daryl Omar Baez complete the NASA poll, getting ready to go into terminal count, and Omar then will report out as part of the launch conductor's poll at L-7. And it was just great to hear everybody giving a go here. That really makes me feel good about the teamwork tonight between the Space Force, ULA, NASA, JPSS-2, and LOFTED, all the teams working together. They had this issue that delayed our T0 a little bit, but they worked through it. They got there. We reset the clock. We're now targeting a 1:49 a.m. Pacific Time liftoff, and just hearing those goes gives me confidence that we've worked through these things and we can get J2 and LOFTED on its way.
And from the shot there, you can see the liquid oxygen that's being vented off.
Flight Control LC.
Go ahead.
Perform launch on time verification.
Roger.
Venting off the LOX for the first stage in the lower part, the middle part of your screen. And then the venting of the Centaur as well. Atlas is fully tanked.
LC, this is the RC on channel 1.
Go ahead.
The range has approved our new T0 of 0949 Zulu.
Roger.
That's great news. Range, of course, has to coordinate the launch time. And, of course, the 30th Space Wing here in Vandenberg is responsible for the public safety of everyone around this rocket. And they also keep track of everything that's in the airspace downrange of this launch area. So it's really important and necessary to get sign-off from the range before you go ahead with your new T0.
Yeah, absolutely. We want to coordinate that with the Space Force, as you said, personnel safety here locally, personnel safety in the airspace as we get ready to launch this rocket, and, of course, personnel safety on the water also as we head downrange from southerly trajectory leaving the west coast of California here. So very important to get Space Force concurrence, which is why working as teams together is a really good thing. Glad to see that we're getting there as we head down into the count.
L-10 minutes.
You heard the L-10 minute call. 10 minutes until liftoff of JPS-2 and LOFTED on an Atlas V rocket.
This is the LC on 1 with a terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. FTS, verify the hold fire switch is in the proceed position.
Ready to proceed.
RLM, verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation acceptable for launch.
Verified.
So there we heard launch conductor Doug Lebo verifying that everything with his team is in configuration as he gets ready to head into the launch conductor's terminal count pole at L-7 and explaining to the team that if they see anything that is anomalous or out of family in the terminal count at T-4 and counting, that they are to call a hold, hold, hold and stop the count. So making sure all teams are ready and understand their responsibility as we get ready to pick up terminal count.
We expect that in just about 90 seconds from now as you look on at the Atlas V rocket in the 401 configuration, the most flown configuration that's been the workhorse of the Atlas V fleet, a rocket that Mick Woltman knows well. It stands at 191 feet tall and weighs 750,000 pounds at launch. It'll throw down 860,000 pounds of thrust at liftoff.
Yeah,
L-8
you said this is the most flown. It is the 41st 401 configuration flown by ULA, and this is the 97th Atlas V. So that gives you a pretty good idea of how many 401s have flown. As you said, it has been the workhorse for not only NASA, but other commercial entities also that have launched satellites. So very proud that ULA has this vehicle.
A lot of science missions over the years. 5 missions to Mars on Atlas V. Also the first the first interplanetary launch from right here on the West Coast.
Yeah, InSight. And one of my favorites, launched in 2006 on an Atlas V, Pluto New Horizons, heading out to the planet Pluto, as I still believe.
Yeah, that's right. Let's stand by for the poll.
L-7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
Com.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Go.
LDA.
Delay clear to launch.
NLM.
NASA's go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 09:49 Zulu.
Verified.
That's the poll we wanted to hear, and the result goes across the board. We are green across the board. That's a good configuration to be in, and a good poll.
5 minutes and 30 seconds.
Yes. NSC, verify spacecraft is configured for launch.
This is NSC. Spacecraft is configured for launch.
So that's another great, right there, poll to hear from the NSC, NASA spacecraft.
All steps are complete prior to the terminal count.
That the spacecraft is configured for launch, getting ready to proceed into terminal count at T-4 when the L clock and the T clock sync up. So very happy to get to this point. Very excited that the team was able to work through their issues this morning or this evening and into the morning and get us to this point, Daryl. This is what it's all about, teamwork in getting a rocket launched with important payload for the United States and the world and Weather Observatory, and making sure that we're doing it safely and having mission success this morning.
This mission to go into a low Earth orbit that is sun synchronous and polar in its direction. JPSS-2 in the same orbit as the first JPSS, which is now NOAA 20, and they will be circling our planet, gathering that weather data that is so critical to forecasting severe weather. We're just a few seconds away from resuming.
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark.
And there we go. We are out of the hold and
355.
now in terminal count.
Enabled.
So from T minus 4 minutes until launch, you'll be listening to the ULA team perform those final steps in the countdown procedure.
Yeah, as we hear the team, they just got the ground pyros ready for the liftoff hold down bolts. We'll hear them bringing up the command sequencers and a few other things, including that flight termination system that we talked about, replacing that battery earlier. And we just hear that hydraulics are at flight pressure. We should be hearing a call out soon that Atlas and Centaur are at flight pressures also, what we call step 3 pressures, which means the vent valves are closed, stopping the venting of liquid oxygen and starting to build up pressure inside the liquid oxygen tanks.
T minus 3 minutes.
Getting ready for launch.
Also transferring the Atlas and Centaur stages from ground
Atlas
facility
tanks
power.
to flight pressure.
There you hear the flight pressure.
250.
Now looking to transfer that power.
FTS internal.
There we go. Coming up in just about 30 seconds, the team will command the launch sequencer to start. That'll be followed shortly by securing the Centaur, liquid hydrogen, and liquid oxygen topping activity. Then just a few seconds after that, the team will command the flight control system to launch, enable, and arm that flight termination system. We swapped out a battery. Some folks here at the hangar getting ready to go outside.
159.
T minus 2 minutes until liftoff.
155.
Launch sequencer start.
There we heard the launch sequencer start you talked about.
Securing Centaur LH2.
Securing Centaur LO2.
Centaur locks and hydrogen have been secured,
140.
allowing them to build up pressure,
137.
getting them ready for flight.
FTS armed.
There's the arming of the flight termination system. T minus 90 seconds.
$120.
Excitement building here at the Vandenberg Space Force Base in California.
We should hear shortly that the Centaur
110.
vehicle is at flight verification.
Vent valve locked.
There's the vent valve shut.
Pressures on their way to flight
T-minus 1
levels.
minute.
Rock, report range status.
Rock, range is green.
Great
Range
news.
is green. Yes, range is green. That's great news. Ready to move forward.
If you're just joining us, we are just seconds away, 50 to be exact, from launching JPSS-2, a new weather observatory that will track storms across the globe as it orbits the planet.
40 seconds.
Stable at step 3.
It will also launch LOFTED, a technology demonstrator developing a new way to safely bring large payloads through the atmosphere. The final seconds.
25 seconds.
Status check.
Go Atlas.
Go Centaur. Go JPSS-2.
There we go, Daryl. Ready for launch this morning.
On a clear night in California, here we go. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And liftoff. Liftoff of the Atlas V, carrying JPSS-2 and LOFTED, a new weather observatory for our planet, and a test for planetary exploration.
Atlas VU has gone to closed loop control.
Yeah, Daryl, as we heard Omar Baez say, LSP-100 on its way also. We're very happy for this 100th mission, the Launch Services Program. Let's listen in as Jesse Gonzalez.
And coming up on 30 seconds from the flight, vehicle is a half-mile in altitude, 2 miles downrange, traveling at 160 miles per hour. And passing 45 seconds of the flight, continuing to see good operating parameters out of the RD-180.
The power of the Atlas V RD-180.
Coming up on a minute into flight, the vehicle is ending its roll maneuver, and vehicle body rates are looking good.
Getting ready and approaching Mach 1.
And passing through 80 seconds into flight, Mach 1, Atlas V is now supersonic.
That's 769.
And vehicle is now passing through max Q, maximum dynamic pressure.
769 miles per hour, 1,234 kilometers an hour. Going through the area of maximum dynamic pressure on the vehicle.
And passing 100 seconds into flight, seeing the RD-180 throttle back as expected. Engine response continues to look good, and vehicle body rates continue to look good at this time.
Throttling down just a little bit to reduce
Coming
the
up
stress.
on 2 minutes into flight, the vehicle is now 12 miles in altitude, 7 miles downrange, traveling at 1,500 miles per hour. And passing 140 seconds into flight, the vehicle has gone to closed loop control, continuing to see stable body rates throughout the boost phase.
So the rocket was flying in a trajectory that's programmed in, but now closed loop is taking positional feedback from the rocket sensors to get it into the proper line for trajectory. It's going to maintain that ascent line. Beautiful shot there on board.
And RCS is now pressurizing to flight levels.
A shot from our infrared camera.
And the reaction control system has reached flight levels. System response looks good. Vehicle body rates continue to look good as well. Seeing good response out of the RD-180 engine.
Going to start cooling down that Centaur engine in the second stage to prepare for its super chilled propellants to flow through the booster.
About 3 minutes and 15 seconds into flight, vehicle is now 53 miles in altitude, 67 miles downrange, traveling at 5,800 miles per hour. And now seeing the RD-180 throttle back to maintain a 5.0 G acceleration limit. Engine response continues to look good.
We're just seconds away now from booster engine cutoff.
And we did see a good response on the Centaur systems as it completed boost phase chill down. And we have BECO, booster engine cutoff. And we have successful stage separation.
With stage separation,
and
now onto the Centaur.
On the RL-10. And we have ignition for the first burn. RL-10 start parameters look good. And we have good indication of payload fairing jettison.
Saw a shot of that booster floating off into space.
Yeah, you can actually see the 4-meter fairing going by there too on the video. That's a great thing. Looking at the telemetry data, RD-180 performed very well on the first stage. Separation was clean. Payload fairings, you can see on the infrared video there on the screen, the booster falling away and the two little fairings. Start pre-start.
Coming up on 5 minutes into flight, this first burn will be about 13 minutes in duration, the first of 3 burns for today's mission. Continuing to see stable RL-10 chamber pressures at the beginning of the burn. And also seeing stable body rates following payload fairing jettison.
RL-10's performing very well. Pre-start was good. Ignition came out very well, as we saw in the video, and as the Centaur continues to burn nominally, body rates on the vehicle look very good with payload fairing gone. JPSS-2 exposed to the environments of space.
As it warms the motor catalyst beds for operation.
Explain quickly what a body rate is.
So the body rate's the attitude of Centaur as the vehicle is moving through space. We're trying to keep everything as stable as possible. So we have an X, Y, and a Z body rate on the Centaur, and the flight computer and the RCS system continue to maintain that as we move through to get ready for separation.
And now we're moving to ULA's real-time animation.
6 minutes in flight, the vehicle is now 250 miles in altitude, 430 miles downrange, traveling at 9,400 miles per hour.
The animation is informed by real-time data. At the top of the vehicle is JPSS-2. And there you're looking at the RL-10 and continues its burn.
And coming up on 7 minutes into flight, continuing to see stable performance across all Centaur systems, stable tank pressures, good performance out of PU, and some minor roll adjustments as Centaur optimizes the telemetry link.
Centaur with plenty of performance to get there.
Plenty of performance, and everything's looking great. As we heard Jesse say, everything is performing nominally as we get ready to continue this burn for separation.
We're going to keep watching the data and listening to the launch team as we track the performance of the Centaur getting JPSS-2 into orbit. But in the meantime, let's send it back to Megan.
If you're just joining us, I'm NASA's Megan Cruz, bringing you live launch coverage from Vandenberg Space Force Base along the central coast of California. Just about 7 minutes, 34 seconds ago, we watched as a United Launch Alliance Atlas V rocket lifted off at 1:49 a.m. Pacific time, and it was a spectacular sight. What a clear night, no clouds in sight. That rocket just lit up the dark sky. It's flying 2 important missions today. The primary one is to send JPSS-2 into orbit. It's the National Oceanic and Atmospheric Administration's newest joint polar weather satellite. The secondary mission is called LOFTED, which will demonstrate a new type of heat shield that inflates for atmospheric reentry. We're going to stay with you live for every important mission over the next 2 hours. NASA's primary launch site is Kennedy Space Center in Florida, but we lifted off from California this morning because of the rocket's flight path. By launching on the West Coast, teams kept the rocket from flying over land. JPSS-2 is a polar orbiting satellite which will circle the Earth pole to pole 14 times a day. As the Earth rotates underneath it, it will pass over every single spot on our planet at least twice a day, collecting valuable weather and climate data. Once operational, JPSS-2 will be renamed NOAA 21. And when you open the weather app on your smartphone, you'll be using NOAA 21 data. NASA's Jasmine Hopkins joins us with how the National Weather Service uses the satellites to keep you informed.
Joining us now is Jim Yo from the National Weather Service. Thanks so much for being here, Jim.
A pleasure to be here to talk about JPSS-2 and how the Weather Service is going to use data from it to get the best possible forecast for the nation.
Absolutely. And speaking of that forecast, most of us check the weather before we even leave the house in the morning. So what are the applications of JPSS-2 data?
Well, the Weather Service will use JPSS-2 data as the basis for making numerical weather prediction models run for forecast of 3 to 7 days, but we'll also use those data for making seasonal to season forecast and to monitor long-term trends for climate science.
Right, and that's great to see that it can help us from day to day and also long term as well, right?
It's very versatile.
Absolutely, and speaking of versatile, I know that NOAA has provided a huge suite of different satellites from JPSS to GOES as well. How does the National Weather Service use them all together?
We use data from the different satellite systems in the Weather Service in complementary fashion. So JPSS-2, by being a polar satellite, will collect data around the world, every spot, twice a day. And that's really important for making a longer term forecast, because today's weather here typically starts somewhere else several days earlier. Now, hurricanes start off the coast of Africa, move to the east coast, or we look in the west coast here in California, and you might see the so-called Pineapple Express storm that comes with strong rains from the Pacific that are precipitated in California and other places on the coast. So we use those to get that long-term forecast, but then we use GOES, which are like sentinels on each coast, to provide that fine-scale, up-to-date adjustment in our forecast.
Right. That's great to see how they work together and understand that it's not just local, it is global weather systems, which is huge. So speaking of that, I know that we're all very eager to get the JPSS-2 data in our hands. How soon will it be available to the end user?
Well, the end users will start to see it in forecast in a matter of months. Typically what happens is the instruments on a new satellite will be turned on one by one, and then they'll be checked out to make sure that the instruments are performing as expected and that the data are what we think they are. We'll compare them to the JPSS-1 data, for example, and then they'll go into the numerical weather prediction models, and so we'll have a seamless transition from one JPSS satellite to the next one.
Right. Well, we're looking forward to seeing that data. That's very exciting. Jim Yo, thank you so much for joining us.
My pleasure to be with you today.
Absolutely. Back to you.
Today's launch marked the second this year, made possible because of the NASA-NOAA partnership. Jim and Jasmine actually just mentioned it. GOES-T lifted off from the Kennedy Space Center back in March. Now renamed GOES-18, it keeps continuous watch over the western U.S., Mexico, Central America, and the Pacific Ocean as a geostationary satellite. That means it rotates with the Earth, remaining in a fixed position in the sky, unlike JPSS-2, which again will fly pole to pole. Having constellations of both kinds of satellites gives NOAA a complete picture of our Earth's weather and climate. JPSS-2 is the third in the latest series of advanced polar orbiting satellites, and boy, they travel fast. It only takes 90 minutes for them to go from the North Pole to the South Pole and back up to the North Pole again. And every time a satellite flies over a pole, it transmits data to two primary ground stations, so you don't have to wait long for a weather forecast. One station is near the North Pole on Norway's remote Svalbard Islands, you see right there. The other is at a station in Antarctica. Antennas at each ground station collect data from the satellites as they pass over. Receivers capture the data, which is then fed into computer models and then to you via weather apps and forecasters. JPSS-2 will do more than warn you of severe weather and help you to plan what you wear each day. NASA's Jasmine Hopkins is back again to show us how the data it collects can also be used to forecast crop yields and how much you pay at the grocery store.
Joining us now is Irene Parker, Deputy Assistant Administrator Systems for NESDIS. Now, Irene, what does NESDIS stand for?
NESDIS is NOAA's National Environmental Satellite and Information Service. And basically what it does is providing satellite and observational data for the nation, specifically for weather and climate.
Wow, okay, a big title. You've got a pretty big job then. So tell me, we understand that JPSS and other satellites like that can help predict the weather, but they can also help us understand rising prices at the grocery store. How does that work?
Oh yeah, people don't realize how much this information from this satellite actually affects their day-to-day lives. So for folks like you and I going to the grocery store and you see those costs of that apple or that banana, that information is really coming from and being supported by our JPSS-2 satellite systems. So the data that the JPSS-2 instruments collect, they're allowing scientists to predict droughts, and it also tracks the greenness of crops. And that information goes into a product called the Vegetation Health Index, and that helps people determine how much food supply the harvest is going to actually produce that year. And based off of that, that determines what that price of that apple, that lettuce, etc., is actually costing us at the grocery store.
Wow, so it's really helping us in that day-to-day life.
It is.
They're also helping us better understand our changing climate. How is that working?
So the way it's helping us with our changing of our climate is that it is providing us continuous data records for the past 40 years. So NOAA has been basically operating polar satellites since the 1980s. So what's really key is that we continue these observations, and the JPSS-2 satellite is going to continue these key observations to be able to monitor the climate change. So basically it's tracking data such as changes in our temperature, sea ice, clouds. It's tracking ocean color information, and all that information is being used by scientists to determine how the climate is evolving. And what it really is also doing is it's actually even taking information above the Arctic, and it's able to see how the Arctic is changing. So you can measure how the change in the sea ice have been happening over the years. And that really helps the scientists and the community to see how climate is changing around the world.
Irene, that is awesome. A lot of great data that we're getting from these. Thank you so much for joining us today.
No problem. Thank you for having me.
Absolutely. Back to you.
We're now just moments away from main engine cutoff. Let's go back out to Daryl Nail and Mick Woltman, who's been monitoring the launch team for us.
That's right, Megan. Thank you. Back here at the Mission Directors Center, joined by Mick Woltman, engineer with Launch Services Program. I'm Daryl Nail, as you mentioned, and we are tracking the JPSS-2.
Minutes into flight. A little over a minute remaining in the burn. Continuing to see very good performance out of the RL-10.
That's a good sign. RL-10 burning well.
Continuing to see very stable Centaur body rates.
Yep, very stable flight for Centaur through this whole burn. It's about 12 minutes, 51 seconds, roughly somewhere in there, as we get ready to come up on main engine cutoff 1 for this first burn as we get ready for JPSS-2 separation, Daryl. So we've been watching the telemetry live here on the animation from ULA through their SDK. Things look really well.
Yeah, the burn expected to last right around 13 minutes. Putting JPSS-2, the Joint Polar Satellite System 2, into its proper polar sun-synchronous orbit. You're looking at animation reflecting real-time telemetry. Just now T-minus 20 seconds until that burn is finished.
And standing by for MECO shortly.
It also...
And we've had MECO 1, main engine cutoff.
You can see that reflected in the animation. We saw a little bit of movement by the reaction control system, which is also reflected here.
And now seeing the RCS system fire at 100% settling.
Yeah, so what the Centaur's doing now is trying to settle the propellants inside the tank. Yep, as we get ready to finish up this burn and get ready for J2 separation about 11 minutes from now, as everything gets ready to go and they start powering up all the systems on the spacecraft, making sure it's all ready to go prior to initiating a separation command.
Will coast for a little over 10 minutes prior to JPSS-2 separation.
All right, so that direct inject, just a few minutes away. We're going to monitor the progress and continue to do so. In the meantime, let's send it back to Megan.
After JPSS-2 coverage is complete, we will shift our focus to LOFTED, the low Earth orbit flight test of an inflatable decelerator, basically a new heat shield. We will have live commentary of that demonstration right here on our broadcast, but right now here with me is Tanya Laughinghouse. She is the program manager for technology demonstrations at NASA. Good morning to you, Tanya. I got to ask you, why is this new inflatable heat shield so unique?
Well, LOFTED is essentially a test flight of an inflatable heat shield, and all prior flight tests of this technology have been suborbital. So that means they go up and then they come back down. Well, today's test will actually be orbital, so we'll do a full orbit around the Earth and come back. And once it does that, the energy is going to be so much greater, and so we're really excited to see how it performs at orbital velocities.
And how could this technology be a game changer for future missions into deep space?
Well, absolutely. So when we're trying to land a spacecraft into the thin atmosphere of a planet like Mars, we need a really big heat shield in order to slow it down safely. And previous heat shield diameters have typically been limited to the size of the vessel that it's launching in. And so what's so great about LOFTED is that its heat shield is pliable, so you're able to fold it and compact it very tight into the spacecraft. And so that means you have additional room for for other high mass items that are needed for crewed mission to Mars. Items like oxygen sensors, like entry vehicles, habitats, rovers, etc.
So I see the space applications, but you and I were also talking about this earlier, that there are Earth applications for this technology as well.
Absolutely. So in NASA Space Tech, we love to say that technology drives exploration. But another huge objective for Space Tech programs like Technology Demonstration Missions Program that I manage is that they are directly aligned with NASA's strategic objective to develop technologies that improve the quality of life here on Earth. And a prime example of that, Megan, to your question, is the spinoff tech from the heat shield materials, the materials that we make the heat shields. NASA and the U.S. Department of Agriculture developed a prototype to improve a fire shelter that protects firefighters, and it's made from the actual materials that come from LOFTED.
Tanya, thank you so much. I love when we can draw those parallels again, how we could use things in space, but also the same technology here on Earth. So thank you so much for that. And at the top of this broadcast, we told you today's launch was LSP's 100th mission. As we mark this milestone, team members look back at some of the missions that got us there.
All my mark, time on T-minus. Status check, proceed with terminal count.
And now coming to us through a downlink from a T-7.
Rocket formation.
T-minus 10.
Inlet type T002. T0 is planned for 0205.
And liftoff.
You never forget your first. And my first mission I worked was the demonstration of autonomous rendezvous technology. Basically, it was demonstrating the technology of autonomously docking to spacecraft in space. At the time, I didn't really understand or know what that technology was being used for, but now that technology is being heavily used today.
My first assignment was Lucy as a backup integration engineer. I felt overwhelmed at first, but I started to realize I had the full support of my management team. I had all of their years of experience that I could count on as sort of standing behind me. We hit our mark. We launched on the first second of our planetary window that we've been targeting for over 3 years.
Sojourner was my very first. Ever since that mission, I've been a part of every other rover that has landed on Mars. Spirit and Opportunity, I was also the launch director for MSL and Curiosity. So those are always something that I could look back and say, wow, I was fortunate enough to be in the right job, to be able to do this and do my little part to make that happen.
After experiencing my very first LSP mission, I think is when reality hit me that I get to be a part of this incredible team that's making history, really, and is helping all of humanity, which is amazing.
The heat shield test we'll see later today is led by NASA's Langley Research Center in Hampton, Virginia. Let's head back over there with NASA's Angelique Herring, who's with the LOFTED team. Angelique, tell me, what are they preparing for now?
Hey Megan, over here the team is waiting for the re-entry vehicle to actually power on. That will in a lot of ways mark the beginning of today's LOFTED demonstration. After the re-entry vehicle powers on, it'll be time for the heat shield to actually start to inflate. During that time, it'll go from its stowed size to the full 6-meter size in the 10 minutes or so that it'll take to inflate. And that will be a really exciting time. After that, there'll be separation, and then the real-time beacon will turn on, transmitting the data that the team will be monitoring here at the Flight Mission Support Center. Now, the team here, a lot of the members have actually been working on LOFTED for over 10 years since it started right here at NASA Langley Research Center. And that might be why they are particularly excited to, explore today and see just what the HIAD technology can do and what LOFTED can show us about that technology. For right now, though, we're going to be waiting anxiously for the official start of the LOFTED demonstration with the turning on of the re-entry vehicle and that real-time beacon. With that, we're going to head back over to you.
But before LOFTED, we must successfully deploy JPSS into space. JPS weather satellites are considered the backbone of NOAA's global observing system. NASA's Jasmine Hopkins spoke with one of the scientists on this project.
Joining us now is Jim Gleason, project scientist for the JPSS flight project. Thanks so much for being here, Jim.
Thank you, Jasmine. Glad to be here.
Of course, we're glad to have you. So you work for Goddard Space Flight Center in Maryland. Can you tell me, what does Goddard do for JPSS and other weather satellites?
Well, NASA and NOAA have had a 50-year partnership in launching weather satellites for the nation. And Goddard Space Flight Center is where those satellites are built for NOAA. We get together with NOAA, they decide what they want their satellites to do, and we at Goddard, we build them, we launch them, check them out, and turn them over once they're all running properly.
That is awesome. A great partnership, and then it comes all the way over here to Vandenberg Space Force Base in California for launch. So
exactly. So we're at the tail end of the process for JPSS-2. We'll have a successful launch and checkout, and then the JPSS-2 data will be joining all the rest of the polar satellite and other satellites in the NOAA system to make the products and forecasts that everyone depends on.
Exactly, and just as you mentioned that satellite system, JPSS-2 has 4 very complex instruments on it. Can you tell me your role and your focus on those?
Well, each of the 4 instruments does something special for NOAA. They're incredibly complex. They measure the temperature of the atmosphere, they measure the temperature of the surface of the ocean, various look at how green the vegetation is, aerosol, smoke. Complicated instruments are hard to build. They have many requirements, and it's my job to make sure that the instruments perform to what NOAA needs so they can make the products and services.
Right, that's a pretty important job then, making sure that they all work correctly. And some of these complex instruments have also been on previous satellites in the system. So why is it important that the data is consistent?
Well, there's 2 kinds of consistency. There's the consistency of JPSS-1 and JPSS-2 and hopefully 3 and 4, so that the forecasters have a kind of data that they're used to and they don't have to change their weather models too much to adjust for the new data. They like a consistent product. From a long-term perspective, we have invested in satellite data to measure the Earth for decades. And by putting those satellite data records together over the decades, we can understand if there's any change. So we are connecting data from the POSE satellites in the 70s to the JPSS satellites in the 2020s.
Wow, that is awesome. Very consistent data over decades.
Decades.
Yeah, absolutely. Jim Gleason, thank you so much for joining us. Back to you.
Okay, we're now minutes away from JPSS-2 separation. Let's head back on over to you-know-who, Daryl and Mick.
All right, thank you, Megan. Yes, we are here awaiting the separation of JPSS-2, just seconds away. Mick, this is the big moment.
Yeah, that's what we've been waiting for, right, to get this primary mission, JPSS-2, separated and on its way to participate with J1 and NPP, delivering weather data for us. So exciting here as we get ready for this separation event.
SVSEP shortly. Continuing to see stable performance across all Centaur systems.
We're expecting that separation in just about 22 seconds.
And we've had good indication of separation of the JPSS-2 spacecraft.
And there you have it. Separation of JPSS-2.
And Centaur is now completing its collision avoidance maneuver following spacecraft SEP.
And you saw the folks there in the ULA launch control room with a round of applause and some handshaking going on.
And seeing the Centaur body rate stabilize following the turn to the CCAM attitude.
NASA launch manager Omar Baez getting some congratulatory handshakes.
JPSS-2 project manager Andre Dress there congratulating Omar, and I know Andre's very happy as well as the JPSS team to have J2 separated and on its way. As we heard, Centaur performed a CCAM maneuver. This is a maneuver to make sure that Centaur is out of the way as it gets ready to restart its engines for the next phase of this mission for LOFTED, that we don't hit into the J2 satellite. So things are going well with the mission so far, and settling, and RCS continues to work on the Centaur vehicle.
Mission Manager Sean Daly there at the far left of your screen. Years of hard work paying off now, Mick.
Yeah, a lot of these folks have spent a lot of time working J2 to get it to this point and working through stuff.
And passing 30 minutes into flight, continuing to see stable body rates out of Centaur. Centaur will coast for approximately another 15 minutes prior to MES-2. Continuing to see good performance out of RCS, very stable tank pressures, and very stable body rates as well.
And as you look at this animation of Centaur, there's still a vehicle attached to it. That's LOFTED, encased at the end, the far left end of the vehicle, LOFTED inside of a payload adapter that once held JPSS-2. It's now been released. And this is the second part of the flight, the primary mission now accomplished. We're looking for that acquisition of signal from JPSS-2, but also transitioning now to the LOFTED tech demonstration.
Yeah, absolutely, Daryl. As the team is continuing its slow playback of some of the data through the TDRS network for that video that we hope to see a little later. The team is also waiting to hear about acquisition signal of JPSS-2, making sure that it's power positive and getting ready to perform its tasks with solar array deployment and powering up some of the other systems as they get ready to bring JPSS-2 completely online for its mission.
And while the mood is celebratory here at the Mission Directors Center in Vandenberg, California, for a lot of the folks here and the team here, our thoughts and prayers are with our family, loved ones, and friends who are back home in Florida as Hurricane Nicole made landfall just about 30 minutes ago in Vero Beach, according to reports. It's weakened now to a tropical storm, but of course that's just 60 miles south of our base camp at the Kennedy Space Center in Florida. And so, as I know you've been texting your wife, and I have mine, getting updates about the action of the storm there and how that's impacting the area. We've got some strong winds that our home center is currently experiencing. That's something certainly on our hearts and minds.
Yeah, definitely thinking about it, Daryl. But, you know, I also sit here and think about the fact that we just launched a weather satellite, another one. I'm very thankful for the weather satellites we have up there already in the JPSS-1 series and the GOES series that work together in conjunction with each other to determine our weather data and bring forecasters most accurate data they can for situations just like this that we're experiencing over in Kennedy Space Center in Florida. So ironic or very heartwarming to know that we just added another satellite to this constellation to help the nation.
Well said, Mick. Certainly JPSS-2, that's its wheelhouse. It's severe weather.
Absolutely.
All right. We're going to keep monitoring the situation. We're going to be looking for that next burn.
33 minutes into flight, continuing to see stable body rates out of Centaur. We have seen the RCS system go to 100% settling.
Good report out there from Centaur. We'll keep monitoring it, but for now, we'll throw it back to Megan.
And to celebrate the launch of JPSS-2, NOAA asked for photos of the places you love, places the satellite will protect by observing the Earth, atmosphere, and our oceans.
Still resides. Homecoming. Homecoming, homecoming. She said, show me what you got, babe. I'm not like other girls. Just give me your bad self in a place for us to make a stand, and I can move the world. Lift the valley from the floor, honey. Little town to the sky. They'll say that it's a miracle, and you'll know damn well they're right. Damn well they're right. Homecoming now. Homecoming, homecoming. Homecoming now. sights. Homecoming, homecoming, homecoming. She said, show me what you got, babe. I'm not like other girls. Just give me your bad self in a place for us.
To see the rest of that video and all of the pictures you shared with us, because we got a ton, just take a look at the screen there. We're going to put up a QR code. You can scan that QR code to see the rest of the pictures. It's really worth the watch, and again, as a reminder of how beautiful our planet is and why it's worth protecting. Real quick, here's my picture of a place I love. I took this photo about 3 years ago now in the Philippines, which is where my family is from. I just love the vibrant blues and greens of that photo, but I really chose this picture to hammer home how weather satellites help us all the time. Because while I was on that trip, a volcano erupted. Airline officials used weather satellite data to track the amount of volcanic ash in the sky to let us know when it was clear enough to fly home. Now let's head back over to Daryl and Mick. Again, as they've been saying, we're still waiting confirmation of acquisition of signal. So let's see what we have now.
Megan, we have confirmation of that acquisition of signal we can report out to you. So good news there. The JPSS-2 weather satellite now communicating with ground stations, and yet another thing to celebrate with regards to this weather satellite.
Absolutely. Solar array deploy confirmed. So the satellite is looking very healthy. JPSS-2 team is very happy with this. So very happy to hear from Omar Baez, our launch manager, that we did acquire the JPSS-2 satellite, and everything's going well.
And now we're awaiting some imagery. Some video from Centaur of that moment of separation for the JPSS-2 satellite. Looking forward to seeing that. But in the meantime, want to point your attention to the animation that we're looking at. That's the Centaur facing in a downward position with LOFTED aimed in that direction. And there's a good reason for that, Mick.
Yeah, as we get ready for this next burn will take Centaur and LOFTED into a lower altitude, which will then begin the operations for the LOFTED demonstration mission as they get ready to do their work, and then have them separate and then do their re-entry here into Earth. And we're going to hear a lot more about that later, but excited about the LOFTED mission and the things that it is going to demonstrate for us for future missions to Mars and possible hardware recovery for rockets.
Absolutely, and we are flying T plus 37 minutes and 50 seconds into our flight. It's been a good one, launching at 1:49 a.m. Pacific time, 4:49 a.m. Eastern time. Awaiting now some imagery downlinked from the Centaur that shows the moment of separation for JPSS-2, the Joint Polar Satellite System. That's going to provide advancements to improve the accuracy of our weather forecasts, something we certainly appreciate now more than ever with a storm, tropical storm, blowing through Florida, our home base. Again, we have we had successful separation of the JPSS-2 spacecraft. And minutes later, got acquisition of signal from the spacecraft. The Atlas V 401 rocket delivering that JPSS-2 into what's been described as a nominal injection of JPSS-2.
And coming up on 40 minutes into flight, about 6 minutes remaining in the coast, continuing to see good performance from RCS. Very stable Centaur body rates near null, and very stable battery voltages and temperatures as well.
We talked about a number of dedications, Mick, in the pre-launch portion of the show. want to revisit one of those, and that's the dedication to Mark Levesque. In 2007, Mark accepted a position with United Launch Alliance at Vandenberg Air Force Base, where he worked as a test conductor, an anomaly chief, and achieved his lifelong dream by rising to the position of launch conductor for missions launching on Delta II, Delta IV, and Atlas V rockets. Levesque retired early, but was diagnosed with cancer in 2018 and passed away 3 years later. Mick, I know you knew Mark well, worked with him for a number of years. It's nice to have this mission dedicated to him.
Yeah, the team, NASA LSP team and the United Launch Alliance team are very happy to have Mark's name on this rocket. He was an incredible engineer, incredible mentor, incredible friend to a lot of us. Mark was one of the smartest guys I knew on the launch ladder logic in the electrical systems here at Space Launch Complex 3. I had the privilege of working for Mark in 1999 when we launched AC-141 off of this pad, and for several missions later, not only as a NASA employee but a ULA employee. And his dedication to space and to continuing that education to others was just amazing. Mark was an amazing guy, and he will be missed by all of his teammates.
And his wife was here to watch the moment.